You are listening to N is for Networking. I'm Ethan Banks with Holly Metlitsky, and together we explore the big ideas of networking, helping you understand how things really work and why things are the way they are. Because we didn't start with EVPN, you know. So follow me and Holly on LinkedIn and chat with us on the Packet Pushers Community Slack group, which you can join for free at packetpushers.net/community. And today I want to chat with Holly to share my take on network design. And I've built or rebuilt many networks over the years, Holly. I've identified 4 goals of network design as a result of my years of experience designing and building networks. And, and let me put it to you this way. These are goals that I believe pretty much every network has. And these goals I use to help me make decisions when building a new network or updating an old one. And for those of you out there listening, because some of you are like really experienced and you have opinions about things that you share with us. Okay, this is my take on things. This is Ethan's take on things. And so you might read like a network architecture book from some brilliant author and they express their information and their opinions differently from me. That's okay. That's fine. I'm sharing from my experience, study, and also the aggregated wisdom interviewing hundreds of network engineers over the years, like things I've picked up and been able to kind of add to my philosophy. Just saying it's okay if what you hear, my take is a little different than your take. We can talk about it. That's good. So Holly, let me hand off to you with this question. You have a job as a sales engineer for Juniper Networks. How much does network design come into that SE role?
So this question, I thought about it. I read the script and I thought, it depends a lot on what type of an SE you are and where you work, the size of your company, and specifically what type of customers you deal with. So for me, I usually deal with large enterprise customers, which comes with very knowledgeable network engineers who most of the time know exactly what they want. They might want a bit of guidance on hardware specs, and maybe some advice and tips about their network, but I am yet to encounter a customer who's happy to let me design their network. And
Hmm.
aside from that, I don't think I'd feel comfortable designing a network when I don't have years and years of experience of the to-dos and the don't do's. So I would pull in, an architect or someone who is more of a specialist in network design, if it's data center for that, if it's just
Hmm.
campus for that. So while I think I'm usually kind of on the sideline to network design specifically, I don't necessarily make the big decisions. I've engaged in those
Yeah.
conversations and maybe I've provided some guidance here and there, but I've never designed a network like from ground up.
Right, right. Which makes sense considering you're newer to the industry and all of that. And a lot of how I came to how I think about network design has come from that experience. That, as you point out, you're like you haven't done some of those things yet. You're not there yet. So that makes sense. It also speaks to how I would interact with my various account rep SEs. I would lean on them for technical knowledge of the products we were considering buying, and I was usually like a technical lead role, something like that. And
Hmm.
I understood what we were trying to get done and like what the next maybe 3 to 5 years probably looked like for the business as best as the business had explained it to us in IT. And so I was thinking with those things in mind and kind of had a design in mind. And I was trying to understand, well, okay, what hardware, software should I be buying that are going to help the business meet those goals over the next 3 to 5 years? That's going to be within their budget and so on. So right, I wouldn't have been looking to you to design the network, I guess, in that case. But I would have been looking to you to be like, hey, I need a box that's probably got this much TCAM because no, I don't need it today, but we're probably going to need it in 3 years,
Yep.
considering, et cetera. We'd have those sorts of conversations and you'd help point me in the right direction or say, I don't know, I'm going to go do some research and then get back to me with some specs and that kind of thing. So
And
yeah,
I
okay.
think I think the other thing is how often do you bump into a project where somebody's building a network from scratch? Um,
Mm,
Especially, I'd say nowadays, often it's maybe a refresh, and if you're refreshing someone's network, they know what they've done, they know what they don't want to do. So they've kind of built that idea around what they have and how to move forward, like you mentioned. So I can't guide somebody or redesign a network that I've got no experience in, because it wouldn't really be an educated design.
Yeah, that's another really big point you make, that a brownfield network is by definition forms certain constraints. It's like you say, really rare that you get to do greenfield from the ground up, brand
Yeah.
new. Let's build this thing like the reference guide says we're supposed to go, go, go. That just doesn't happen very often. And that brownfield network, it's like, I have to coexist with this thing. We're changing the engine while the plane is flying.
Yeah.
That limits us. There's only so many things that we can do. So whatever you might want to design might be impractical anyway. Well, all right. Let's get into what we mean by network design. We've been hinting around it, but I'll tell you what I think, Holly, and you can tell me. You can react
Hmm.
here. I mean, when I say network design, I'm trying to describe the way in which a network comes together, the big picture, the whole, the network as a system. A network isn't a switch, it isn't a router, it isn't a firewall. It's the whole system coming together, those pieces and parts fitting together. More like the network is a tree, not a branch on the tree, right? And so network design is, what does that look like? How do all these different pieces and parts come together to deliver a certain kind of value for a business? How does that resonate with you?
Yeah, that's kind of how I think about it. I think as someone again who's never designed it from the ground up, the idea of it is actually quite overwhelming because I think,
Yeah.
okay, all these sure it's a big picture and you've got to think of, all the different boxes that you need, but then you have to think about perhaps some optics, some speeds, how are we going to connect all of these boxes, what protocols are we going to use, and then
Mhm.
suddenly this general big picture becomes very technical and very deep very quickly. So it's at what point does it at what point do you I guess you never stop, but it's like, you have to have a big picture, but I guess where do you start? And I guess that comes to your 4 goals maybe.
Yeah, well, right, because it's very easy as engineers because we love the details to get
Yes.
mired down in like, is this going to be, OSPF or BGP is our baseline protocol? Oh, are we going to combine the two, overlay and underlay? And you start going crazy about all these little details and what your spanning tree design might look like and how you're going to do your VLANs, VRFs, and so on. I was like, whoa, 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 whoa. What is the big picture? Zoom back
Yeah.
out, zoom back out. And I think that is the difference between a network engineer and an architect. Like you mentioned, you might have an architect you can draw from to help you as an SE provide a design that a customer might need or some recommendations in that regard. Architects can think at that big picture level and understand how all the minutia will fit together to deliver a design. And in my case, deliver on what I think are the 4 goals of network design. So let's name them. I got stability, speed, scalability, and security as the 4 goals of a network, and they all start with S, which made me happy.
Was that a coincidence?
No, I mean I didn't force it too hard, but it did kind of come naturally. But I was like, oh, cool, they come with S. They all start with S, and that did make me happy. But I didn't like sit here and go, I have to come up with 4 words that start with the same letter. I didn't I didn't do that. It just kind of worked out. So again, stability, speed, scalability, and then security. And we're going to talk about each of these in turn. I'll tell you why I think these are important. Um,
I'm
well,
thinking if
well,
I would
let's.
include anything else, and I think you've covered I feel like they are wide enough terms that you can cover a lot of things under them, so you've got your bases covered. So I'm curious to see if we get any pushback
Uh,
on these 4 goals, but to me, I think it really covers what you're looking for in a network.
if any of you out there have fifth or sixth goals, they have
Mhm.
to start with S, or they don't qualify. Just so you know, it's okay. So anyway, why did I pick these 4 goals? I mean,
Yeah.
I think these are important in a context of why a network exists. A network exists to meet business objectives, right?
Mhm.
There's a business, there's an organization, they've got some service, some product, some function that they exist to deliver. And the network supports that goal. That is, a network doesn't just exist because it's cool. And I've worked in a lot of environments where We nerds just love to nerd out about things. Hey, I have an excuse to learn about this new thing I picked up in this training class or I read about in a book, and I want to try it. And all of a sudden, your network is like a science experiment for you.
Yeah.
It's your big lab, only it's in production. That's not why a network exists. A network exists because the business needs it to exist to do what it does, and without that, the business could not do what it does. And so stability, speed, scalability, and security are all there to in the biggest context to deliver on some business goal. And Holly, companies aren't coming to you because, hey, we got money to burn, and what's the latest from Juniper that we can spend our money on, right? No, they're
I
trying to
wish
solve
they
a
were.
problem, right? Yeah.
That would be a best case scenario, but no, like you said, it's they've got a need. Something, I guess what they have is not providing the solution that they require. Maybe it's speeds and feeds, maybe stability, maybe things aren't as stable as they would like, and they need to solve a problem to make some sort of improvement.
Yeah, exactly. Exactly right. And from a business perspective, there's going to be a budget that's tied to that to accomplish whatever the goal is.
Hmm.
All right, so let's walk through the four goals one at a time and see what we think here. So, stability. Again, going back to that business context, well, every business relies on technology in the modern era. That's just the way of it. I mean, even something you don't immediately associate with technology, like a landscaping business, there's still technology
Yep.
involved there. They've got accounting, they've probably got scheduling, they've got a web presence. There's technology that's important to their business pipeline. On some level, every business in the modern era relies on technology, and access to that tech, whatever it is that the business relying on, is critical. You got to have it. If you don't have access to your tech, you probably can't do business. And so, therefore, that's where this goal comes from of stability. The network's got to be reliable. You got to be able to take the network for granted. It's just there. It's invisible. It's like electricity. It's like water. You just assume that that service is going to be there, and that means the network is stable. It's not up one day and down the next, and fast one day and slow the next. And it's stable, it's predictable. It just does the thing you're expecting it to do, which is deliver traffic in a way that you can count on. So stability. How does that feel to you?
It's a very broad term, because I think what makes the network stable? Is it redundancy? Is it, I don't know, like time to convergence? Like, I think when you start looking at that, there's so many things to consider. And this is me being the engineer who can't look at a bigger picture. Um,
No,
but it's a good place to start because it needs to be stable. And from there, like you said, kind of like you can turn it into a tree of what are all the pieces that you have to find and put together and design for to make it big picture stable.
that's exactly it. The goal, if the goal is stability, as an architecture, I want this network to be stable. Okay, that is a characteristic, a goal that I have. Right. Then the next question becomes, from an engineering perspective, what do I introduce to the network to meet the goal of stability? And like you said, like redundancy. Okay, I have an internet connection. My internet connection must stay up because this business relies on public cloud and a bunch of SaaS services to do what it does. If we don't have internet, we can't do business. So redundancy might come up. Okay, we're going to have two internet connections at a site, and if one goes down, the other one will keep going. Um, and so that redundancy means you're not a victim of the single point of failure of your one connection to your one ISP falling over, causing you to be incapable of doing business.
Yep.
Wireless access points. If you're providing wireless to your physical premises, sorry, physical Yes, premises. Sorry, there's a there's a lot of pedantic people about premise versus premises, and so I always got to make sure I'm using the right word. A premise is a guiding principle, or
Yes.
whereas the premises is your physical onsite. Yes, there we go. So if you're covering your carpeted floor space, as they say, with wireless, you don't do it with one access point, even if a single access
Hmm.
point might physically cover the whole area you're trying to cover. You have multiple access points in strategic areas, not only for redundancy, but also for load management and so on. That helps you with stability. If one wireless access point falls over, has a problem, reboots itself, loses power, whatever the scenario is, everybody can fail over to the other access point. Might they notice a little hiccup in between associating from the old one that fell over to the new access point that's going to cover them? Yeah, but generally speaking, that's stable. If you had access points failing all the time, then I would say that's
Yeah.
not stable. But and the occasional outage. But yeah, I think you get the idea, and this is why conversations that we've had about things like spanning tree, come into play. One of my sayings is, "Your network is not a democracy. Rig every election." Well, why? Because stability. That's part of it. If you're forcing a particular network design by not allowing the network to just elect some device to be a particular role, then you're enforcing a topology, a design that is intentional and that hopefully would lead to stability.
Are these in a particular order? Before we get into them, I just want to make sure, are these just the four things or have you ranked them?
I I did rank them, although I think I'm a little squishy on that. That is,
Hmm.
yeah, we could probably move some of the stuff around, and arguments could be made to move stuff around. But I will say that to me, these are in order of importance. But the last one of security is kind of hard to rank, I guess. That would
Yeah.
be the odd man out. That's more difficult for me to rank because it underpins um the other ones for sure. So it's, I don't know. There's no
Well,
there's no one right answer here.
a stable network is not stable if it's got security issues all the time. So,
Yeah, it or an insecure network, right, could lead to instability or
yeah.
poor performance or other challenges. So I will say a lot of my roles over the years as a network engineer, I've been brought in kind of as the fireman to put fires out, and the
Mhm.
fires were related to stability problems. We have these outages, this doesn't work, and no one knows why. Then all of a sudden it's working again. I've been brought in to deal with those sorts of challenges. So stability from a business perspective is usually the number one, in my opinion, the number one concern
Mhm.
for a network. Number two goal then would be speed. Is it fast enough? Is the network fast enough to do what we're asking it to do? Which is a capacity management problem. If the
Yeah.
network's too slow, again, it's under spec. It's got bottlenecks in certain places, not enough link capacity to handle traffic flowing through a particular point, or there's gray failures, just odd things happening on the network where it's not an outage, it's just slow. The network's not slow, not fast as you would expect it to be. That prevents timely access to the technology that the business relies on. So, like the internet being slow. There was someone in the community Slack channel who was dealing with uh, during the day when students were on her campus. She was in an educational institution. The network, her internet access was just terribly slow, and it's brutally impacting the school's ability to deliver classes because a lot of the services they deliver rely on some internet service. And she's going nuts trying to figure out what the problem is because it actually doesn't seem to be capacity. They had a big internet pipe that was not full, and went through all this other troubleshooting. But at the end of the day, it felt like a speed problem. Things were not
Yeah.
fast enough when all of the students were on campus doing what they do. Um, and so speed is really important. You feel those bottlenecks where everything's just like you hit OK on a web page, and it's like things aren't coming back. If it's the network that's causing that problem, because it could have been the web server, you don't know, but until you do some diagnosis, you don't know. You can know, but you might
Yeah.
not know initially. If the network's slow, man, it sucks and it's annoying. Yeah, the network's stable, but why is it? Why are things slow? And so I think speed is another
Yeah.
goal here.
And I think speed is very dependent on your use case because you don't need ultra low latency switches if you, I don't know, school, for example. But the impact of slow is different. So this is a tough one to spec because it's really dependent on what you're doing. And I think it's very
Mm,
easy to just want the greatest and fastest and the best, but sometimes you don't need that necessarily because couple milliseconds to you and a couple milliseconds to another use case could be a very different meaning.
A couple milliseconds in the average LAN probably doesn't mean much. It might, but we probably don't feel it. Whereas you were talking about ultra low latency switches, where we're getting down into nanoseconds
Yeah.
of difference from port to port latency, depending on the switch and how it's spec'd, which can matter for very specific applications like high frequency trading, where the company that is using their high frequency trading network to trade stocks, the difference between them making a few pennies or a few bucks on the trade versus not could come down to nanoseconds, because the value of the stocks that they're trading against can change that quickly. And so their ability to harvest just teeny tiny fractions of a second to make their trade and then make money really matters. Does that matter for most of us? Nope, not at all. I mean, you and I are talking across a wide area network with have real time high def video
Yeah.
and sound, and it's fine. And we are definitely milliseconds away from each other, however long that is. Presumably relayed through some Zoom data center somewhere. I don't actually know if Zoom uses hubs or if we're talking direct. There's different ways they might be doing that, but we're milliseconds apart for sure. Doesn't matter. We're
No,
working.
not bothering me.
It's working. No, this is all working just fine. So, but I agree with you that it is easy to overspec on speed, and speed is one of the things you got to be a little careful of, because the temptation is, like you said, I want the biggest, baddest switch you'll sell me. It's like, yeah, do you have truckloads of gold so you can buy that switch? Because that's
Like,
what
no,
it
just
takes.
discount it a lot, but I want that one. Like, do you
Yeah,
need it though? Do you really need it?
really need. Exactly. Do you need 800 gig? We're in 2025 as we record this, where 800 gig is pretty much the latest and greatest Ethernet out there. Do you need that? What is your use case for that? Oh, well, I am a hyperscaler and I am training my latest large language model on the entirety of the internet. Oh, you probably need that then. Okay. I'm a mom and pop, and I run a network of car washes. Yeah, no, you don't need 800 gig. No, you definitely don't, for sure. so so right, because you do pay for speed, so it's very helpful to understand. Know your flows is what I would
Yeah.
say. Know your traffic. Understand what's going through your network, and how much, so capacity, so you have enough speed to handle the load. And then also latency. What are the latency requirements of the application that are driving those flows? Both of those things may dictate your choice in speed, or what the business can justify to
Mm.
spend on speed. Speed's another tricky one, though, Holly, because in the sense of a lot of network purchases, it's 3 to 5 to 7 to 10 years, all depending on who's
Yeah.
buying it. There can be some longevity there. So you also want to plan for the future. What you need today will be different from what you need 3, 5, 7 years from now, too.
Yeah.
So that is another piece of it. Yeah, I don't know if you get customers that are like, but what should I buy? Because this thing's got to last
Yeah.
me for a long time.
And also, especially if you've got a growing business and it's, well, today we don't really need that, but we're planning to expand 2, 3 times in the next 5 years. So I think we should spec for that. But it's a very challenging conversation to have, because what you could buy now could be far cheaper, but you don't really want to refresh your network every year. I mean, you don't. It's not
No,
going to happen.
no,
So you need to
it's not
find a
fun.
balance of planning for now, what you can afford and what you can do. And also, like you said, not overspecking to think, oh, well, my company is going to grow 10x in the next 5 years. Realistically, is it? Maybe not.
Yeah,
So
yeah.
it's a tough payoff to figure out, what do you actually need, what might you need, and can you meet in the middle perhaps.
Mm. Another piece is looking for bottlenecks. That
Yeah.
is it slow because most of it's fast enough, but there's this one place where you're pumping too much traffic through a particular uplink that's going from, one part of your campus to another part of your campus, or is your wide area network just too slow because
Mm.
you need bigger pipes to get you into the cloud or to the internet? Those bottlenecks can make the whole network feel slow, even though it's really just one link that happens to be a critical link with a lot of traffic flowing through it that's underspec, and you can fix everybody's feeling of a slow network by fixing that one link. It's another piece of the puzzle. Again, that speaks to network design. It's seeing the network as a tree, not a branch.
Hmm.
Looking at the big picture and understanding what's happening, Might mean you need to trim a branch or work on something. I don't know. The analogy of a tree is going to fall apart, but the but tweaking the one thing that can make the whole thing work better.
Yeah.
All right. So as we talk about stability, we talk about speed. Now let's talk about scalability. Scalability, number three. Do you know what I mean by scalability? Do you know what I'm getting at?
Yes, this is the only one that I'm not like, I don't know. I mean, it is a fundamental. I'm not going to say your goals are wrong, but if I think of scalability, I think of something that needs to, I guess, be able to scale. It's a great way of explaining it. No, but should you, like we were speaking about before, should you have to expand the network? Do you need to add in certain features or, more capacity or things like that? Do you have to rebuild the network in order to improve it, or does it scale with, let's say, a growing company or growing user base or things like that? Um, do you always need scalability?
There's a big it depends here, but I'll tell you what the why
Hmm.
I put this in from my experience. The idea was put in a network design such that if I need this thing to get bigger, it's easy to make it
Yeah.
bigger. I can scale it. And there's two aspects to that. One could be something like a leaf spine network in a data center.
Hmm.
If I spec a big enough spine, I can add leaves at will and bring in more racks into that leaf spine architecture without having to make significant other changes or without having to add more spine nodes into the network. I can just add leaves as long as I've got enough capacity in the spine to grow those leaves over time. So bigger upfront investment in the spine switches, right? I'd have to have more port capacity, more forwarding capacity in those spines than I might otherwise have to make. But it means when it comes time, it's like we need 3 new rows of racks. We got a project coming in. We're bringing in a bunch of servers. We're making that investment as a business. What do I got to buy? And I'm going, oh crap, the spines are already maxed. And all of a sudden it's like this annoying, difficult project,
Yeah.
as opposed to, yeah, we planned for this. I've got 3 empty line card slots in the chassis spine switches that we purchased. All we got to do is slap another line card into the spine, and then we can add as many new top of rack switches for the leaves as we need. That would be an example. Another way to think about it would be, what do I need to do at well, like I guess wireless access points might be another one. Is it easy for me to add more wireless access points to this system? Should be, should be easier to do that. I can scale that out. Oh, we just took over this additional 100,000 square feet of floor space. Okay, that's a big number. 10,000. There we go. That's more reasonable. Feet of floor space in this office building. Yeah, no problem. Okay, yeah, we got the back end port capacity for that. All we got to do is buy access points, and we can deal with it. Maybe we got to add a license or something
Hmm.
to accommodate the additional access points. Can I make this thing go bigger in an easy way when I need to go bigger with it? Or if I put in the system that maybe today is cheaper, am I limited in the future where I can't grow this thing?
Yeah.
It's not easy for me to make it bigger without a holistic change, without a significant change. That's a part of what I'm getting at as far as scalability goes. Um, Another way I like to think about it is it a replicable design? And I like to think of networks in terms of modules. And we talked about this in some of our early episodes. We zoomed way out and said, what's the internet? Well, it's a network of networks, right? And
Yeah.
then if you look at your individual network, it's a smaller version of a network of networks. You might have your different LANs, you might have a data center network, you might have a wide area network that all connect together to form a unified network. So if we take that idea and say every part of my network is a module, can I grow it? Can I make it bigger? So I'm going to invest in an SD-WAN technology, software defined wide area network. Okay, what solution do I pick? One of the network design goals here, if it's scalability, you might invest in a solution that will scale to the number of nodes you expect to attach to the software defined network module, if you will, so that we're going to acquire 100 new locations over the next 2 years because we're a company that does a lot of merger and acquisition activity. I need an SD-WAN solution that's not going to max out at 500 nodes because we're already at 450. We're buying another 100. I need a solution that can scale bigger. And so you invest in the solution that will allow that scaling to happen without it being, this SD-WAN solution cannot handle any more nodes than this. We're done. There's no more locations we can attach to this thing. It's maxed out. It's not. It's going to fall over. It's not designed for this. It was designed for smaller sites. We need to invest in the bigger one. Scalability. Those are the examples of what I'm getting
Mm.
at.
And I think if you take this back to the fact that we building networks for businesses, usually, there's a reason why you have a network. The odds of a business staying exactly the same size over the next 5 to 10 years is hopefully quite low, because I don't think
Right.
that's a great business model if you're never expanding or never growing. So I think that's, to me, why scalability becomes really important, because it's one of those limiting factors that if you don't plan for it, it's going to be much more challenging to expand down the line. So you're saving yourself kind of headache up front by considering this in the beginning.
Well, it can be. As far as whether or not your business is growing, because
Yeah.
it's an interesting point you make. Your business, the business you support doesn't have to be growing to be successful. That is, there are businesses that just run in a more or less steady state. They're
Hmm.
not growing, but they are profitable. And so they're
Yes.
happy to just keep running along in a similar size to they are where they are today. And so one of the things you kind of learn to ask as a network engineer or a network architect is to have a good relationship with the business where they're telling you what the plans are, or at least as much as they're comfortable telling you. They're not going to tell everybody all the things, because a lot of times things don't happen and people get all excited about nothing. But understanding broadly where a business is headed over the next few years can help with those decisions. And if you're aware of those things, you can put a buying recommendation to the business in those terms and go, okay, guys, you've told us you're planning to do lots of acquisitions over the next years. If we buy this system today, that is going to support the acquisition. It reduces our time to bring the business in-house that we've acquired down by a factor of 6 weeks or whatever it is. And and the things that it all gets quantified to money. At the end of the day,
Yeah.
I'm going to spend more for the solution, but then at the end, whatever, and some bean counter figures it out, and I go, yeah, okay, thank you, we're gonna do that. Um, 'Cause scalability is part of that. Going back to my notion of replicated designs. Uh, and acquisitions, or expanding into different offices, if you can do the same thing everywhere as you do in the main office, let's say you make every office look like a miniaturized version of the main office. Oh man, there's such big wins there for you as a network operator. You get this consistent operational knowledge. I know how to do it in the main office, and I also know how to do it in the remote offices, because we didn't buy the one solution here and a different solution here and here and here and here. And so there's been shops where I've worked where we did do a lot of acquisition, and part of the acquisition was, and we are going to convert their network to look like all the other networks that we
Yeah.
support here. We're not going to have this odd person out. I put that under the heading of scalability, because it's a different, but I mean it in a somewhat different way. It scales you as a team. You can support a network that's homogeneous, that looks and feels the same from site to site, with a smaller number of people than otherwise. Otherwise, you need more knowledge. You need, if something's got a mix of Arista and Juniper and Cisco, that which isn't uncommon. There are a lot of multi-vendor networks out there, but it is a bit harder to manage and keep up with that thing than if you've got everything same everywhere. It doesn't, in my
Yeah.
opinion, doesn't really scale your people as well, your team, your operations function as well, and puts you at a little bit of knowledge risk. The key person who knew how to do the Juniper stuff just left the company, etc. Whoever the specialist was, that was the one person you went to do that thing. So,
Yeah, I think that that idea of the replicable design is actually really important, because I don't think it's spoken about enough. Um, So when you start creating or designing these intricate fancy networks, and then suddenly, maybe you've got another location popping up, and now you've got to go back and start thinking about, oh, actually, how did I design this really cool quirky network? If you just
Mhm.
make sure from the start, like, oh, we have some sort of consistency, and it's a kind of like you can copy and paste and put it somewhere else. I'm seeing this with a customer at the
Yeah.
moment. We've got a design, it's they know that they're going to do some other locations, and they've designed it for exactly that, and that comes 100% into the scalability. If we looked at other designs, but they weren't as replicatable,
Mhm, mhm. Right, right,
um
yep.
and like that would cause a lot of headache if they weren't. So it's really important to think about that.
Yeah, yeah, you reminded me of another piece here that I think falls under scalability, which is, simple. You don't network design, it should be as simple as possible, but no simpler. I've heard it put that way. Simple as
Yeah.
possible, but no simpler. But again, going back to engineers and being nerds, and we love nerd knobs and features. Yeah, don't turn any of that stuff on that you don't really need. That is, you're turning a feature on because it's solving a specific problem. It's addressing a network design goal, not. I read about this in a book and I think it's so cool. I want to try it. No, that's not. You don't do that. You do that in your lab for fun. You don't do that in production. So again, as simple as
Yeah.
possible, no simpler. Because as you were just saying, you got that customer, you can put these different designs, or you can put the same design in these different locations, and it works pretty well. And for me, I used to follow this principle. The only thing that would change would be the size of the hardware that was going out the
Yeah.
door. Maybe I might need a bigger switch or something more robust or whatever in a bigger location, and it'd be the same thing but a smaller version, of
Hmm.
that switch, sent out to a little the other smaller site. It'd all work the same, just I didn't spend so much to deliver that functionality to that smaller office.
Yeah, and I think one other thing that I'd like to add here that's quite important is the odds of the same person managing the specific network forever is close to zero. So if you come
Yeah.
in and design a super complex network that doesn't have all these got all these quirks and features because at that time you thought it was cool, and now it's 10 years down the line, you've left the role, and
Yep.
you've the network engineer coming in comes into this very interesting network. It's really tough to then figure all of that out and scale or build up or plan for the next 10 years because they're spending the first 2 years working there figuring out what on earth you did.
There was a network I worked on. I'm laughing because it was like that. I started logging in and looking at configs and I'm going, what are they doing? What what is this disaster? Policy-based routing through an IPsec tunnel bounced off. What is happening right now? It's like, why didn't they go with the straightforward way that was like obvious to solve it in a much
Mm,
more straightforward way? And you just see all this drama in the configuration. You're scratching your head going, what? 'Cause you can't support that. Like you said, when you're gone, and your name is Rube Goldberg, and you leave the Rube Goldberg network behind you, and someone else steps in to look at this monstrosity of complexity that you've built, that is not sustainable. And it's also not sustainable even if you still are at the company, because you shouldn't be
yeah.
the one human that works on the network. You should be able to train six other people on the fundamentals of the things in the net. Yeah, there's going to be specialized, complicated things that maybe you're the one, because that's why you are who you are. But you should be able to train people on all the basic stuff and have it be easy and predictable and not like, wait, I got to do these six other things to accomplish this one thing? Well, yeah, because of this and that. And then over here, we got that access list. And then, no, 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 no. Again, as simple as possible. No simpler, but as simple as
Yeah.
possible should be the goal. All right, stability, speed, scalability. And then the last one is security. Uh, and my idea here is that a secure network supports the goals of stability, speed, and scale. But this is another really broad topic. If the goal of a network is to deliver security, there's a bunch of layers and ways that we can think about this. So we can think about network security, securing the network infrastructure itself. So that is a stable network is one that is resistant to attack,
Yeah.
for example. So there should be things like we can control the management IPs. We can limit which IP addresses on the network are allowed to engage in management activities of that network device. If anyone else tries, they're denied. They're go away. That traffic is dropped. Things like RBAC, role-based access control, where if Ethan logs in, he's got limited capabilities. If Holly logs in, she's got full admin rights, and something like that, differentiating between different roles on the network. Protecting control plane protocols so that not just anybody can spoof being a BGP neighbor, but you're actually signing, encrypting that traffic and so on. So you can do the same thing with lots of other routing protocols where there's some kind of encryption involved, authentication involved, so that you're not forming a neighbor relationship with just anybody. You can do things like out of band management that puts a channel to manage the network outside of the regular network that can help you from a security perspective because you've got a way to restore the network if things go south. Maybe someone would think it's a stretch to include that in security, but I don't. I think
I think
it's
that's
a, it's
pretty important.
yeah, it's pretty key out of band management. And I haven't had it everywhere that I've worked because some shops thought of it as a luxury. And it's like, especially in the world of automation, if
Mm,
you automate something and fail at scale, where you did an automation and blew up the whole network, and you need to recover it, you want that out of band
yeah.
management channel so that you can get control of the network you just blew up. You don't want to have to ride on your automation traffic to rebuild the network because the network's gone now. You just killed it. You need an out of band network to cover that. So securing the infrastructure itself, that's one layer. Defending against attacks against your network is another one. So these would be things like DDoS mitigation, distributed denial of service attack. In a DDoS, there's different styles of them, but one of them is to just fill your inbound pipes to capacity with junk so that you're incapable of doing business. It's a distributed denial of service. It's one form of a DDoS attack. How do you mitigate against that? Usually, you got to partner with someone upstream from you to help you with those sorts of things. But that would be an defend against attack sort of strategy. BGP hijacking. Are you able to handle it if someone else on the network on the other side of the planet announces your internet public network and people can't get to you now, or some people can't get to you now? Can you help defend against that? Things that every network engineer, if DDoS mitigation, BGP hijack, those sound like, oh, it's exotic. I just, I don't care about that kind of stuff. All right, right, right. DHCP snooping, you probably care about. We talked about this when we talked about DHCP. We mentioned it in passing, Holly. But that's where you're actually monitoring for DHCP traffic flowing through your switch. And if the switch sees a DHCP offer come from an unauthorized port, oh, shut that port down. That's a DHCP server that shouldn't be offering anything. That could be a man-in-the-middle attack happening. Spanning tree guards would be another description. This, I shouldn't see a root advertisement coming in across this port. Root guard, kill
Yeah.
that port. BPDU guard. I shouldn't see a switch on the other side of this port. So if I see an inbound BDPU when I'm only expecting host traffic to come in, shut that port down. That kind of stuff. That's security. That's all these things are tools that help with security. They can help with, or I'm sorry, there are things that help with security, but they are security tools that help with stability for sure. You're helping maintain a stable network by defending against these outside influences and bad things happening. You can help with speed because certain of these attacks can definitely impact the speed, the performance of the network, depending on what they are. Um, And with scalability, I mean, we're stretching it a bit here, I guess, to say that it also supports a scalability. But I feel that it does in a certain sense, because if you've got a network that is properly secured, again, it doesn't take as many people to keep the thing
Mm.
up and running. If you know it's stable because you put all the right guards in place, you're helping with that scalability as well. We can grow this, and we didn't need to add a headcount. We're going to be fine. Um, other kinds of security, just one more thing I'll mention here is what the network itself is doing. It moves traffic around, right? Well, the network can be an important security layer. We can control things that control the traffic flowing through the network with access control lists, like firewall policies. We can segment the network with VRFs, for example. We can support multi-tenancy. These are all ways that we're securing the network too. And so I feel like security underpins those other three
Yeah.
of stability, speed, and scalability. I don't know how well I made my case, but that's kind of how I think about it.
I think I'm yet to see a network that doesn't take security into account in any form. And I think one thing that's key is when you said security, immediately I thought like normal networking security, like firewalls and, DDoS mitigation and those kinds of things. But actually securing, like you mentioned, securing the network itself is really important. That out of band management, things like that, it's fundamental to managing your network. And without that, all sorts of things can go awry. And that's how it links to stability and everything else. And
Mhm.
you can't have a stable network without making sure it's secure. I just you leaving room for problems. That's really what you're doing. So if you want a stable network, you've got to cover your bases, and that comes from security.
I'll throw some homework out for anybody that's interested in this particular topic of securing your network infrastructure. Just look up security hardening guide or router security hardening guide. You will get I haven't done this search for a bit, but I know I'm going to guess Juniper's got one too. But I know Cisco used to have a rigorous security hardening guide for network devices that would talk about. I just mentioned a few things kind of in passing, so you kind of get the point of what I was saying. It was far from a comprehensive list. Security hardening for a device is like that's an exercise, man. There's a lot going on and a lot to think about. And they talk about the management plane and the control plane and the data plane and how to think about those. They get into things that there's a whole show we can talk about control plane policing, which is a bit exotic, but maybe not really a network fundamental, I don't think, which is more what we try to focus on here. But it's an interesting topic, something good to be aware of. So, okay, Kali, we talked about the four goals of network design: stability, speed, scalability, and security. But the big asterisk is it doesn't always work out the way you want because
Yeah.
you can have these goals, but you're working within some kind of constraints, right?
Hmm.
We don't have to spend a ton of time here, but I just wanted to point out that any sort of network design starts out from this point of idealism. This,
I have $500 million to make the most
right.
amazing network on the planet. I
Exactly.
want everything
Yes.
to be 800 gigs and low latency.
Yep,
No.
exactly. Yeah. And then you're constrained by budget. Your number one constraint in any network design is going to be budget. And it can be more painful than it needs to be sometimes. I've worked at a lot of places where the networking component of the budget for whatever the bigger project
Yeah.
was, it was an afterthought. You're like, oh, we're going to acquire this company. We're going to do this. We're going to do that. And we should call IT. And then the IT person goes, we should bring in networking. And it's like, we're doing, okay, well, we're going to need to buy this, this, and this. And we're going to need to do this. And someone's going to need to make a trip. What's our budget? Oh, your budget is $0. We didn't
Yeah.
think about that. So now you're trying to like, what are we going to do?
Next year
How are
you
we
can
going to make
have a
this work?
network.
Yeah, exactly. And that is the reality. Sometimes the network
Mm.
design, you got to make do with what you got. You just do the best you can. Okay, I have no money for budget, but we're acquiring this company. We've got to be connected to them as soon as possible after the acquisition closes. IPsec tunnel. They probably have a firewall. We have a firewall. Boom, let's stand up a VPN tunnel, do some routing, and off we go. It's not great, better than nothing. You're not telling the business no and that they're dumb because they didn't think to budget for enough IT infrastructure to support their thing. But it is what it is. So with budgets and stuff, I wouldn't be resentful because they didn't buy the thing I really wanted them to buy. Because businesses don't have infinite money, right?
Yep.
So my strategy would be I'd explain them options in terms of risk. If you buy this solution that costs more money, you've mitigated risk X, whatever it is. If you buy this other solution that's cheaper, then your risk exposure is this instead. And in 3 years, you're going to probably wish you'd spent more money today. And then business leaders, you don't have to explain all the tech to them. You don't have to dive in and go, "Wow, the TCAM on this box is bigger," and you don't have to get into all that. You just explain in plain English business terms what the risks are of going with solution A versus solution B versus C, and and then they make an as informed a decision as they can based on what their
Yeah.
constraints are. They don't have all the money. You're like, it's a huge company. Of course they have all the money. No, they don't. No, they don't. These things are limited.
And they
I,
might, but it's not going to be for the networking. It's just,
it's not. It's not going to be for the network. It might be for the executive golf tournament.
yeah, very
It might
important.
not be
Marketing
their
budget is
priorities.
very important.
And you're going, an executive golf tournament is so frivolous. My word. No, that's a sales event. You know what's happening at the executive golf tournament that you didn't get invited to? They're talking with other people that are going to buy their stuff and making deals. That's how business gets done in a
Yeah.
lot of cases. You're looking at something that's to you stupid and trivial. I can't believe they denied my budget request for X. Yeah, you don't get what's all going on though. You're a bit myopic as an engineer a lot of times. So anyway, budget's always a constraint, going to be probably your biggest number one constraint to fight. And you got to
Mm.
learn to talk business to help your goal is to help the business stakeholders make as smart of a decision as they can. They may or may not have the ability to do the Cadillac solution, if you will. But that's not up to you. You do the best with what you've been given for budget and go from there. So another constraint is team capabilities. Do you know what I'm getting at with this one, Holly?
This actually comes up in nearly every conversation that either we don't have the expertise to deploy that solution, we have no one who understands
That
this tech, or, oh, there's me and two other people at this huge conglomerate and we run the network. So I don't have the capacity to do X, Y, and Z because there's just not enough hands
Yep.
all the time.
You nailed it. That is it. That is a constraint. The perfect technical solution might not actually be something that you have the wherewithal to handle. Or there's only one person on the team that can do that, and they're spread too thin, and it's just not
Hmm.
going to happen. Yep, that's just very practical constraint. The last constraint I'll throw out there that I've run into a bunch is vendor relationships. I want the solution from vendor A. You can't have it because we have a relationship with vendor B. You have to buy it off the vendor B list. If they don't have the thing, then we can look at vendor A. Otherwise, you got to buy vendor B. Those are the contracts. That's the deal. But the solution from vendor B sucks. Too bad.
Yes. I
Yes, the SE
as
says.
yeah, as a vendor, somebody working for a vendor, this is I think probably one of the most challenging things that I navigate. Where you come in and you trying to explain, or you even deal with customers that know that your solution is better, which is the most frustrating thing in the world, but they only buy from this vendor and we appreciate how fantastic your solution is, but our executives has a relationship here, so that's where we buy.
Going back to the executive golf tournament.
Yeah,
Yeah, that's another
exactly.
way business gets done. Yeah, that's so the executives made a deal over a handshake. Their kids go to the same school together. That is going to override what the quote unquote best technical solution might be, or even a cheaper technical solution
Yeah.
sometimes. Yeah, you can win on price, features, functionality, and still lose the deal, or still not get to buy that thing that you want to buy because some other vendor relationship is in place. Uh,
Yeah, which is an
yeah.
interesting role, like part of my job, because often I can win over an engineer quite easily because I understand engineering speak. I can show you something that's going to make your day to day way easier, but you aren't the one buying
Yep.
most of the
Yep.
time. So you can sit there and be like, wow, this is awesome. This would make my day so much better, save me this amount of time, but you don't control the budget. So I'm selling to you, but you have to sell internally and you have no idea what's up the chain, what conversations are being had. There's just a whole world of complexity outside of what we see, and it's very interesting.
Another piece of that is the nature of you might have a contract. Your company might have a
Mm,
contract in place with a vendor, and
yeah.
the terms of that contract are you get a 67% discount as long as you buy $100 million worth of volume from us over the course of a year. And so there's no way you're not buying from that vendor, because that
Mhm.
just makes too much economic sense to the accountants to make it happen. So it's like, yeah, but I want to buy from this other vendor. Yeah, you can't though, because we got $100 million buy target this year, and for the new data center build, you've got to go with this vendor. That's how the only way the economics work for this contract. So that's another kind of a thing you
Yeah.
can run into. Yeah, it's just constraints. They're there. They're a real thing we deal with in network design. 100%. There's no, as you said, Holly, the opportunity to do a network design from the ground up and just start from scratch. Those come up once in your career, maybe if you're lucky.
Yeah.
Yeah.
So where do you start? What is the first thing in your list of like decision criteria that you look at? And I mean, like, is it what boxes you need? Is it just the general topology design, which I would start there probably, but like, what is that first step in that big picture? Because I think that's something that I think about and then I dive straight into the complexities and I'm like, I don't even know where to begin.
Well, there's two different ways you can apply the four goals. One
Mm-hmm.
is you're walking into a network that needs help, and so it's not as much about what you're buying as much as figuring out what's there.
Mm-hmm.
That is, you have to understand deeply what you've got before you need to know where to go next.
Yeah.
So a lot of places I've been hired, I would spend the first couple of months, maybe 3 months, doing nothing but auditing everything, building out, ignoring every piece of network documentation I have other than to be aware it's there and glance over it and go, this is probably mostly a lie. And then digging in, um, getting being able to log into a switch that no one knows how to log into because that guy's gone. And doing all that kind of stuff, and then mapping out the network device by device and figuring out what's really there. Um, and then figuring out where the problems are, because
Mm-hmm.
inevitably there'll be problems. And then now we're at the point of, okay, we know what the network is, we know what the problems are. Now, how do we take the goals of the business and figure out what network changes we need to make to deliver on those goals, stability and speed and scalability and security? What do we need to do? And there's certain things you're going to be able to do for free, for cheap, and then go after them and just get those things done. There was a shop where I found the data center was connected to like another data center across the way. That one was used for production, one was used for QA. It was connected by a single 1 gig link. That was it. And believe it or not, there were problems between those two
Really?
environments. Yeah,
Wow. Who
shocking.
would guess?
And so some low hanging fruit I found was there was a whole bunch of cable that were patched between those two sites and a whole bunch of free ports on the two core switches between the two. Okay, light them up. So
Yeah.
it cost nothing, and I changed it from 1 gig to 4 gig, which was still not a huge amount of bandwidth, but at the time, this goes back many years, and at the time that made a huge difference, and it improved stability, gave us some redundancy, and cost $0. So
Mm-hmm.
you identify those quick wins. I identified in one shop they were running an inappropriate, really a closet switch as a core switch, and this thing was dying. They were hammering this thing with storage traffic and database traffic, and the poor thing could not keep up. It was not a non-blocking switch. It didn't have the guts for it.
Yep.
Found out there was a data center class switch sitting on a pallet in a back room. Why aren't we using these? Is something wrong with them? I don't think so. I think everything's fine. Just no one knew how to deal with them. Okay, I've run this particular model of switch at every other place I've ever been. Could we put a project in place to bring these into production? It's going to fix this problem, this problem, and this problem in the data center. Yeah, we can. Let's do it. We did it. Solved the problems, and then went on. Cost nothing. Now, not everybody's going to have a data center class switch sitting on a pallet in the back room doing nothing, but I
Yeah.
mean,
uh,
look for the
Probably
opportunities.
more often than you would think, unfortunately.
There are a number of abandoned projects or shelfware where someone dropped, 50 or 100K on some tool
Yep.
that's doing nothing, and you're like, "This is so cool. Why is no one using this?" Didn't have time, couldn't figure it out, whatever, whatever.
Yeah.
Yeah. So you find those quick wins, and then you get the network to as good as it can be, where you're meeting those design goals as best as you can. And then you go, okay, to go to the next level, we probably need to spend money.
Yep.
This switching solution is inadequate. We need a load balancing solution that's different. We need to change how we connect to the cloud. We've got to upgrade our internet capacity. Whatever the things are, you'll end up with a punch list of bottlenecks you've identified, uh, design elements that limit your scalability, that make it too hard to do things. And if you replaced it like this and made it look like this, it would just be so much easier. And you just start tackling things one at a time, taking into account some of this will be disruptive to the business, so I need a maintenance window. Some of this is going to cost money, so I need budget. Some of this is going to prevent an acquisition from happening smoothly. And so I need to raise that as a flag to the business and then prioritize what we're going to do about it, et cetera.
Yeah.
And it takes time. Most of the networks I worked on, it would be a 2 to 4 year project to get the network to like that place where all the goals
Mm.
were met. We can now grow, we can scale effectively. We've plugged most of the security holes. Things are pretty good. Operationally, it's all documented. Everybody knows what's going on. We've had good training internally. We've standardized on a vendor or our stack of vendors, whatever they are, that do certain things for us. The network management platform is up and running. It's consistent. We're getting good data out of the network. We're confident that we know when a change was made that wasn't authorized, et cetera. All those kind of systems are in place, but it just takes a while to get all that stuff up to snuff if you've not had someone that was dealing with that from the beginning. And a lot of
Yeah.
shops, man, the networks just, I don't know what your experience is coming into different places, Holly, but the networks are neglected, I think is a good word.
Yeah, I think a lot of the time to like you're trying to build a network that just works. You said in the very beginning of the episode, like you can just forget about it. And the
Mhm.
problem is when it does just work, it does get forgotten about.
Forgotten.
And
Yeah.
yes, it works, but is it working at like the most optimal way that it should be working? Well, you haven't looked at it for 10 years, so probably not.
Mm.
Um,
Almost
and they
certainly not
do.
if it's been 10
Yeah.
years. Yeah.
They do. They get neglected. It's quite sad.
Yeah. Yep. 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 Well, it's over an hour. I think this, I don't know if this is our longest podcast, but it might be.
Wow, that
A and I remember I was working on this yesterday, this script for us, and I was like, this won't be that long of a conversation." And once
yeah.
again, we blew it up.
Here we are, chatting away.
Oh, so Holly, I know you're on LinkedIn. Where else can people follow you on the internet? Is that your main one?
Yeah, or the Packer Pushers community Slack channel. I pop in there, read some comments, learn some things. I'm there in the background.
Some great conversations happening in the Packet Pushers community Slack group. Yeah, so you can join that if you want, if you're out there listening. Packetpushers.net/community. Even if you're working for a vendor, we get that question sometimes. Oh, I work for a vendor. Am I allowed in the Slack? Yeah, just don't come in and
Yeah.
be a marketing shill for your company. That's all. Just go in and be a good person, be helpful, and not like buy stuff because it's awesome. That's not what the Slack group is
Or
there
you
for. It's
can
there for
read the
community.
complaints about your stuff, which is very helpful sometimes.
Could be very interesting as people have their hands on with your gear and live it day to day and have these challenges. Those stories come up in that Slack group too.
Yeah.
So anyway, for everybody out there listening, thank you for listening to Ennis for Networking today. If you've got questions, comments, or a request for a future episode, you can hit Holly and I up via packetpushers.net/follow up. And you can find Hollow and me, as we mentioned, on LinkedIn or that Packet Pushers community Slack group. And there's over 3,500 people in that Slack group, and there really are a lot of great conversations happening. Now, if you'd like to watch Holly and I instead of just listening to us, head over to the Ennis for Networking podcast on the Packet Pushers YouTube channel. The Packet Pushers network has lots and lots of podcasts. Ennis for Networking is one of them, and you can watch Holly and I chatting. And we're working on upgrading our video. That's going to happen. We know we're shooting on Zoom right now, and Zoom makes it look like shot on potato. We're well aware. We're working on it. We're looking at some different platforms. We're going to figure it out. And many of you, by the way, have told us how much value you're getting from our conversations, right? Well, you could help out the rest of the community by letting them know too. So the way you do that is you put a like or a comment, subscribe wherever you're listening to the show. That tweaks all the algorithms and so on. And it costs you nothing but a little bit of your time. And let the world know that NS for Networking is a resource for all the new and up and coming networkers that are out there. And last but not least, just remember, networking isn't hard. Other people figured it out, so you can too.